Let's now go the opposite direction. So we now have an x and y coordinate that we need to make polar coordinates. So I showed you some equations that you can use to do that. So x squared plus y squared equals r squared. You just use the Pythagorean theorem, and then theta is you use the inverse tangent function, y over x. So these are really going to be helpful if your value is not on the unit circle. So that's just to like extend it beyond that. But because we're going to be using values that are on the unit circle, I'm going to go show you some quick tricks to find your angles. And if you can't find them, then you just plug them in this way, which would be easy to do even with the quick trick that I'm going to show you. Okay, so you don't have to necessarily remember those. What I always do when I convert to polar coordinates is I go ahead and graph the point. So -4 means I'm going left 4, up 4. Okay, now it's going to be equal, so it's going to be an isosceles triangle. These are congruent. They're both 4. Okay, so like I said, you don't really have to remember this first one, because if you just look at that right triangle you made, you know how to find that last side, our radius. Okay, so now here's the cool thing though. If you have, just ignore that negative for a second. Let's look at the fact that both of those are 4. That actually tells us this is an isosceles right triangle. In other words, it's a 45, 45, 90 triangle, which means the hypotenuse is always the value of the leg, one of the legs, times the square root of 2. So knowing those special right triangles will save you some time. So it's 4 square root of 2. Now you can obviously do the math to do that. Pythagorean theorem, that's fine. Now, you could then also use inverse trig, and that should be easy. You could just see that. You don't have to necessarily show it right here. You can use any kind of inverse trig, actually. You could use inverse cosine, inverse sine, whatever. But there's no need, because we already know that the theta right here is a 45-degree angle. Therefore, this angle has to be 135 degrees. Oops, that looks terrible. 135 degrees. Now I'm going to go ahead and put it in radians. Our radians would be 3 pi fourths, because remember 3 pi fourths is the one that has equivalent x and y values. So I just converted just like that, and I can go ahead and say my answer is 4 square root of 2, 3 pi over 4. So the visual really helps. Let's do another one. So we're going to convert this to polar coordinates. Once again, I'm going to show you my little trick so you don't have to remember those equations. Really, the only equations you really need to remember is that x is r cosine of theta and y is r sine of theta, and that's for the rectangular ones. But those should be pretty easy to remember. Okay, so I'm going to go ahead and plot this. Now, when you have two values that are different sizes, it's always nice to know which one's the bigger value or the longer side. So the y value is actually going to be the longer side because we're multiplying by square root of 3. So this is our short side. Okay, so I'm going to kind of exaggerate that when I draw it. So I'm going to go down, right, sorry, that's left -2, and then down to square root of 3. Okay, so I purposely exaggerate it so it's easier for me to see which angle this is, because remember, I'm not trying to trick you. This is one of them off your unit circle. Well, that should tell you that this angle right here, based on where it's placed, is 4 pi thirds. Well, that should also make sense. We can show you a couple different ways. But for this is actually going to be a 30, 60, 90 triangle. So I knew where to place those. I'm going to ignore the negatives for a second. I'm just going to put positives right there. I knew where to place the 30-degree angle because it's always across from the short side, and 60 is across from the medial length side. So if you remember your 30, 60, 90 triangle relationships, you always have x squared of 3, your x, and then this is twice the length of your x value, or your short side. So our radius is just going to be 4. Now I'm going to always use a positive radius. So technically it could be positive or -4, but it's easier if you just make the radius positive. So we have a radius of 4 because it's twice the 2. And I'm not doing twice -2. I'm just going to do twice just the absolute value of 2 and then 4 pi thirds. And there it is. Okay. So just a quick, easy way. Now, once again, I said this was 60 degrees right here. That means this would have been 180 plus 60, or 240 degrees, which is the same thing as 4 pi thirds. Now, I don't think it technically specifies, so I just think it's good practice to use radians and get more used to that than to use the degrees.